When we need to execute separated threads in our code, instead of instantiating the thread class and passing a reference for a runnable object, we can use a pool of threads. One of the ways for getting one is calling the newFixedThreadPool static method declared in Executors and passing over the size of the pool we want. This method returns a reference for an object that functions as a pool of threads. An object which is a pool we can use for running our separated threads. This code sample includes the declaration of printJob. PrintJob class is a class that implements runnable, meaning we have the method run inside the class printJob. Assuming we want to call the run method on each one of these objects separately in separated threads, instead of instantiating the class thread, we can use the pool of threads in the following way. Each time we call the method submit on our pool of threads object, passing a reference for a runnable object, we indirectly cause that pool to take an available thread, and if there isn't one, and then waiting for an available thread, and use that thread to execute the run method on the runnable object its reference was passed to this submit method. Let's execute this code demo. If we go over the output, we can see how the length of each one of the printing jobs is reflected in what we get in our console. Each time a print job starts, we get the message started, and when it completes, we get the message completed. We can see when we execute this code sample that in the beginning we have 3 printing jobs running. Only when one of them is completed, and in this case John is completed first because John is the shortest printing jobs out of the first 3 ones, only when John is completed there is an available thread in that pool to start running a new printing job.